Part 5, Graphing Polynomial Functions. To sketch a graph of a polynomial function, we're going to sketch just a rough graph. It's not going to be perfect, but it's going to have the important parts on there. First, of course, we're going to draw a coordinate system, put your labels and tick marks, your x and y axis, whatever you need to do so it's clear what we're graphing. Plot the x and y intercepts. Anytime we're graphing any graph, we're going to plot the x and y intercepts, no matter what shape it is. And then sketch a smooth, continuous curve that goes through those intercepts. Make sure it looks like a polynomial. Pay attention to the end behavior. Pay attention to what's happening at those x-intercepts. And make sure that your curve is above the x-axis where it's supposed to be above the x-axis, and below the x-axis where it's supposed to be below. We might not have exact points on there, at least not very many, but at least make sure it's in the right spots. Close enough is kind of what we're going for here. And then extend your curve all the way to the left and right. Use arrows to show what's happening on the right and left, so that it just continues infinitely on the right in whatever direction it's going, and on the left. Let's sketch a rough graph of this function. F of x equals x squared times x plus 1 times x minus 1 cubed. Let's think about the zeros and the multiplicities. We'd have a 0, negative 1, which is multiplicity 1. A 0 at 0 has multiplicity 2. And the 0 at 2, which has a multiplicity 3. We talked about these multiplicities in the last section. Now let's look at the end behavior. The end behavior, let's first look at our first term, our leading term, is going to be positive. So it's going to go up on the right side. Now what's the degree of this polynomial? To find the degree, we can just add the multiplicities. So the degree is 1 plus 2 plus 3, which is 6. And 6 is an even number, which means that we're going the same direction on the left side. So it's going up on the right side, up on the left side. What about the y-intercept? So the y-intercept would be, what if x is 0? So if x is 0, we have 0 squared times 0 plus 1 times 0 minus 2 cubed, which is 0 times 1 times negative 8, which is 0. So our y-intercept is 0. Now let's try to graph this and see what we end up with. We'll put our tick marks. Put as many as you need. I'm looking at my intercepts. They're not very big numbers, so we don't need to put very many there. We have an x-intercept at negative 1, 0, and 2. And we have a y-intercept at 0. That point's already on here. We know that we're going up on the right and up on the left. Now these two arrows are not going to be part of my graph. That's just there to remind me as I graph what's going on. So what does the multiplicities tell us about the graph? Even multiplicities mean that when you get to that x-intercept, you're going to touch the x-intercept and bounce off. An odd multiplicity means you're going to cross through at that x-intercept. So here's what I mean. Our only even multiplicity is at 0. So I'm going to start on the right side. We're going up on the right side. We're going to cross through here. And then at some point, we're going to turn around. But when we get to x equals 0, we're going to touch and turn around because 0 has an even multiplicity. And then again, at some point, we need to turn around so we can cross through when x is negative 1. So that's what my graph looks like. That does match the end behavior that I already said it would be. Up on the right, up on the left. We have our intercepts there. And looking at the multiplicities, our odd multiplicities, we cross through the x-axis. And the even multiplicity, we touch the x-axis, bounce, and turn around. Let's try another graph. Here we have negative 3 times x minus 2 times 2x plus 1 squared. I'm going to put a few tick marks here to help us out. So let's find our zeros and their multiplicities. This factor gives us a 0 at 2, and it has a multiplicity 1. 2x plus 1 equals 0 when x is negative 1/2, and that one has a multiplicity 2. So the entire degree is 3. 1 plus 2 is 3. We add our multiplicities to get the degree. So we have, let's see, an x-intercept at 2 and an x-intercept at negative 1/2. For our end behavior, our leading coefficient is going to be negative. Our leading coefficient would be negative 3 times 1. So negative 3 times 1 times 2 squared. That's going to give us a negative number. So if the leading coefficient is negative, it's going to go down on the right. So that arrow is just to remind me when I graph we're going to go down on the right. Now our degree is 3, which is an odd number, so the left side goes the opposite direction of the right side. Again, those arrows that I just drew are not part of the graph. They're just to remind me what's going on. The y-intercept. So when x is 0, we would get -3 times 0 minus 2 times 1 squared, which would be 2 times 3 times 1 is 6. So we have a y-intercept at 6. So let's graph this. At -1/2, we're going to touch the x-intercept or the x-axis and turn around. We're going to bounce off the x-axis there. But at 2, we have a multiplicity that's odd there. We're going to cross through. So we know that on the right side it's going down. So we'll start down here. We're going to cross through. At some point, we got to hit that y-intercept. And at some point, we'll turn around. And here we're going to bounce off. So my end behavior matches those arrows I had. My even multiplicity right here, -1/2, it does touch the x-axis and bounce off there. The odd multiplicity, I have it crossing through. So I've graphed a really rough sketch of this polynomial. We don't have a lot of points on there, but enough that we can kind of see what's going on. We have the basic shape of the polynomial. Let's create a polynomial with the following characteristics. So we're not going to graph this. We're just going to write what the function would look like. First of all, the solutions to p of x equals 0 are 2, -3, 4, and -4. So we know so far we have our polynomial. We have one factor that's x minus 2. We have one factor that's x minus a -3 or x plus 3. We have an x minus 4 and an x minus a -4, which becomes x plus 4. So that's a start. Let's look at our next condition. The leading term of p of x is -x to the 5th. So we need a negative in front. Right now we have all positive x's inside of our factors, and we need a negative. But now it also says that we have a 5th power. Our degree is 5, and I only have 4 factors there. So we must have one more condition. The third condition, the point -3, 0, is a local maximum. We look here, -3 is an x-intercept. So at -3, I do have an x-intercept right here, and it's telling me it's a local maximum. So I've got to be looking something like that right there at -3. So at -3, I do have to touch and turn around. So that one has to be an even multiplicity. And because the total degree is 5, I can't use a number bigger than 2, or I'd have a degree bigger than 5. So there is my polynomial that matches those 3 conditions.